Hi, everyone. Let's talk about different types of data. In a statistics class, we mostly work with quantitative data. It's the most common type of data. And it's the most common form of numerical data. So the age data in example 1 here is quantitative. George Washington was 57 years old, John Adams was 61 years old, and so forth. And quantitative data is very mathematical. For example, let's say that someday we get a president who becomes president at 35 years old. Pete Buttigieg was almost that. Then Donald Trump, who was 70 when he became president, Donald Trump's 70 years of age would be twice as much as the 35 years of age over here. 35, by the way, is the constitutional minimum to be president. So these numbers are mathematical in the sense that 70 years is twice as old as 35 years. So there is an inherent numerical meaning to quantitative data. Most numerical data is quantitative, such as these ages. So quantitative data, the ages here are an example of that. And then you have qualitative data, which tends to be non-numeric. For example, what's non-numeric here? The names, the actual presidents, the names. Qualitative data tends to be non-numeric, including things like names, the actual presidents here. Also, things like political parties. So for example, Trump was a Republican, Obama was a Democrat. Okay, they're not quantitative, they're qualitative. Favorite colors, what's your favorite color? Red, blue, orange, whatever. Also qualitative, not quantitative, and so forth. Now, instead of qualitative data, some sources use nominal data or categorical data. Other sources might define these a bit differently, but these generally mean the same thing. Qualitative data, nominal data, as in names sometimes, right? Names. And categorical data. These are often interchangeably used. Now you might be going, well, we have numbers and letters, basically. What else is there? Well, let's talk about ordinal data. Put this in green here. Ordinal data. Ordinal data provides a sense of order, and it could be considered qualitative or quantitative. Although ideas such as twice and half might not make sense if you think of these as numbers. So for example, in the president's ages example, in this table here, do you see where the ordinal data is? In this table over here, do you see where the ordinal data is? It's in these columns over here. When you sort the presidents chronologically, what order number did they have? So George Washington was the first president. John Adams was the second president. Thomas Jefferson was the third president, and so forth. Now, ordinal data is sort of in between qualitative data and quantitative data. You can think of these as quantitative in the sense that they are numerical, and they even make some sense here, right? But they're not fully numerical in the same way that the age data is. In a way, they're not fully numerical because, for example, can you think of this mathematically? Was Thomas Jefferson 3 times the president that George Washington was? Is Donald Trump 45 times the president that George Washington was? Is Monroe +2 Andrew Jackson? So those kinds of calculations might not make sense. So yes, ordinal data is often represented with numbers. Washington was the first president, John Adams was the second president, and so forth. But there's not as much inherent numerical mathematical meaning as was the case with the ages. So ordinal data is often in between. Now, what else is an example of ordinal data? Grades. Grades. Again, ordinal data is kind of in between qualitative and quantitative. The order numbers of the presidents look kind of quantitative, okay? But grades look kind of qualitative in the sense that they involve letters, right? So the grade that you get for a class could be an A, a B, a C, a D, or an F. So you might think, oh, that's qualitative. Well, the thing is, though, it's not like someone's favorite color, for example, what people's favorite colors are. It's not like favorite colors in the sense that you do care what you get. There's a certain order here, right? If you're a student, you'd rather have an A than a B, and you'd rather have a B than a C, right? So there's a certain order here. Now, the grades here can be recoded numerically. So if you want to go more from letters to numbers, well, an A is worth 4 grade points. We're going to talk about grade point averages, GPAs, later on in this class. An A is 4 grade points. A B is 3 grade points. A C is 2 grade points. A D is 1 grade point. An F, well, that's 0 grade points. So you can recode these letter grades numerically. Still, these can represent ordinal data, although they look more numerical. They are numerical, but maybe not fully quantitative. Okay, so I guess the letter grades are like ordinal data in the guise of qualitative data. The corresponding grade points here are ordinal data sort of in the guise of quantitative data. All right. Now, again, these are not fully quantitative. Even when you recode the letter grades as grade points, or in terms of grade points, these aren't fully quantitative in the sense that even though a C is worth 2 grade points and an A is worth 4 grade points, that doesn't mean that an A is necessarily twice as good as a C. I mean, in a typical class, an A would be like a score in the 90s on a 100-point test. A C grade would be like a score in the 70s. So grades are not fully quantitative in the sense that, for example, an A is not generally considered to be twice a C, although that might be the case with the actual grade point values. But in terms of the principle, an A student's work is not necessarily twice as good as a C student's work. So grades are not like ages, where 70-year-old Donald Trump would certainly be twice as old, give or take, relative to a 35-year-old president, a younger Pete Buttigieg. All right. Now, what's another example of ordinal data? Aside from the order numbers for the presidents, aside from grades, well, ratings. What's your, so for example, rank the colors. Rank the colors. So what's your favorite color? What's your second favorite color? What's your third favorite color? And so forth. Maybe red is your favorite, green is your second favorite, blue is your third favorite. So ratings. Likert scales. You've seen these in surveys. They involve ratings such as strongly agree, neutral, slightly disagree or disagree, strongly disagree. So these might be 5-point scales, for example, where a strongly agree might be a 5, a weakly agree or just an agree would be a 4, neutral would be a 3, a disagree, like a weakly disagree, would be a 2, a strongly disagree could be a 1. So you can recode these numerically, kind of like recoding the grades here. You can recode these numerically from 5 down to 1, for example. Now, you could even take averages, but still, they're not as numerical as ages, right? Is strongly agree 5 times a strongly disagree in terms of assessing quality? Highly debatable. So again, ordinal data, somewhere in between fully qualitative data and fully quantitative data. The names here are fully qualitative. The names up here are fully qualitative data. The ages are fully quantitative data. Ordinal data, like the order number of the presidents, grades, these ratings, like on Likert scales, okay, they're in between, ordinal data. Another sort of in-between type of data is binary data. Binary data, like yes, no. For example, if I were to ask the students in the class, are you a full-time student? Yes or no? Yes, yes, no, 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 yes, no, yes, no. Or I could phrase it as, are you a full-time student or a part-time student? Full-time, full-time, part-time, part-time, and so forth. Now, again, the data could be considered qualitative because it could be wordy, like yes versus no, or they could be recoded as quantitative data. You could think like a binary computer, right? A yes could be recoded as a 1, a no could be recoded as a 0. So yes, yes, no, no could be 1, 1, 0, 0. But still, that doesn't mean that a yes is necessarily a no plus 1. It's not fully mathematical like that, like the ages are. So as you can see, there are different types of data, and they sort of run the gamut. So we do talk about quantitative data, right? Like the ages, qualitative data, like the names here, ordinal data, which is like the order number for the presidents here, binary data, maybe something like gender. Although for the presidents, that's not very interesting. Male, 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 da, 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 male. 45 males. If Hillary Clinton had won in 2016, we would have had an F for female here. That might have been a bit more interesting. So we'll see if and when we ever get an F in that gender column. Now, 20, 30 years ago, we might have said that gender data was binary data, male versus female. But if you go to Facebook nowadays, there are many, many different types of gender. Back in 2014, it was in the 50s. It's probably more now. Maybe over 100, maybe over 200. So sometimes we come up with different values for a variable. So we go from binary to something beyond binary. All right, again, different types of data. Next time, well, it can get even more complicated. You can take a specific type of data, like quantitative data, and break it down into further different kinds of data. So it's making that taxonomy even more complicated, breaking down larger types of data into smaller types of data, right? Smaller categories of types of data. Next time.